For today's video, you will need your in-class 6 notes from your Standard 2 notes packet. We will be talking about angle addition, which is a postulate, and then angle bisector, which is a definition, and then linear pair, which has both a definition and a theorem. So, as we get started, we are going to get moving by thinking about the measurements of some angles. So, as we look at this first picture, they are asking us to find the measure of angle ABC. That is the rotation that would take us all the way through this larger angle in the picture. So if we start traveling, that part of the angle is 65 degrees, this part of the angle is 35 degrees, so the measure of angle ABC would be 100 degrees total all the way from one side of that angle to the other. If we look at example B, the situation is a little bit different. We've been given the measure of angle ABC as 110 degrees. So from A through B to C, they're giving us this larger angles measure as 110 degrees total. And then the goal is to find the measure of angle DBC. So that would be this smaller angle that doesn't have a measurement marked. So if we think about this total 110, if we were to remove or cover up that 70 degree angle, angle ABD, what would be left would be this angle here that we're looking for. So 110 with that 70 degree angle removed is going to give us a measurement for angle DBC of 40 degrees. Last but not least, in example C here for the intro, they're telling us that angle ABC, so again this full angle, has been divided in half. So this ray BD is dividing that angle exactly in half. Which means if this rotation here for angle DBC is 50 degrees, then this one for angle ABD would need to be the same. Using that idea, measure of angle ABD is exactly what we just tracked down. That would be equal to 50 degrees, so that that angle would be divided exactly in half. So these intro ideas actually show us a couple of the different types of problems we're going to be working through for our in-class 6. The first reason that we will see for Standard 2 is going to be angle addition postulate, very similar to segment addition postulate from our previous standard. And so we are going to think about that as being parts of an angle that can be added together to find the measure of the whole angle. So our general equations are going to be set up as addition problems, very similar to segment addition. We're actually going to look at example A and write a general equation for example A. So if we're thinking about the parts of this angle, this top portion that's 65 degrees could be called the measure of angle ABD. The bottom portion would add on to that the measure of angle DBC, and together those two measurements we added to make the measure of the whole entire angle ABC. So you'll notice we need these little m's in front because we're writing an equation that uses numerical values, not just pictures. So the measure of the two smaller parts of the angle add together to be the measure of the entire angle. We could show our work. The measure of angle ABD was that 65, the measure of angle DBC was 35, and together those make the measure of angle ABC. And so we found earlier and have now confirmed with a little bit more formal work that 100 degrees is the measure of angle ABC. Example B up at the top is also the same kind of idea. We would have angle addition postulate as our reason for the work that we did here, except that the way that we did it was actually in terms of subtraction. So we need to be a little bit careful that we don't accidentally write a subtraction equation for our general equation. We want it to look like addition because our reason is angle addition postulate, not subtraction. So if we set that one up the same way, I think we can actually use the same exact general equation because these letters are all in the same location that they were for example A. So we've got the measure of angle ABD again, that's that top section, plus the measure of angle DBC, that's that bottom section that I highlighted in that orange color that was missing. And together those will add to be the measure of angle ABC, the whole angle. Substituting this time, we'll have a 70 degrees for the measure of angle ABD. We do not know the measure of angle DBC, so that will stay. But we do have the measure of angle ABC, the whole entire angle, as 110. And so that is where the subtraction comes in, the work to solve, which gives us the measure of angle DBC equal to 40 degrees like we had previously. Example C is different. We did not use angle addition postulate for example C. We used this description right here that the angle was divided in half. Another way of saying that that is happening is to use the phrase angle bisector. So this is a new vocabulary word for us, which is why you're seeing definition there as part of this new reason. So now we're up to 2 reasons for standard 2, angle addition postulate and definition of angle bisector. So first and foremost, let's talk about the definition. An angle bisector is going to be a ray, like it is in this diagram, or it could be a line if it kept extending out in this direction, that's going to be in the interior of an angle, so it's inside this angle. And then what that ray or line does, if it's an angle bisector, is that it divides that angle into 2 equal angles. Another way to think about that is that it's a ray that cuts an angle in half. Okay? So when we see that phrase angle bisector, that's what we need to be thinking. A ray that divides an angle into 2 equal parts, or a ray that cuts an angle in half. So for example C, up at the top, we had information about the measure of angle DBC, this part that was labeled 50 degrees. So the measure of angle DBC is going to be in our general equation. And we were asked to find the measure of angle ABD. Well, that's just the other part of that angle. So those are going to be equal to each other, thanks to the definition of angle bisector. The measure of angle DBC was 50, so we plug that in. We don't know or didn't know the measure of angle ABD, so that stays put. And then we land on 50 degrees as the measure of angle ABD. All right, that is 2 of the 3 pieces of information that we said we were going to talk about today. Angle addition, which is a postulate, if we turn it into a reason. Angle bisector, which is a definition. And then we have the idea of a linear pair, which is going to have both a definition and a theorem. So we'll see which one of those we'll use when we're actually solving problems once we fill in this bottom section. Okay, first we need to talk about the definition of a linear pair because that's how we're going to know when we're dealing with a linear pair theorem problem. So a linear pair is going to be 2 angles that are what we call adjacent. We'll explain what that means in a second. And they form a straight line. So adjacent is what's happening right here. This ray, HJ, is shared by 2 different angles. This angle to the left, angle GHJ, and then this angle to the right, angle JHI. So because they share that ray in common, and that's the vertex of both of those angles, we can call those 2 angles adjacent. Then the other sides of those angles, so ray HG and ray HI, are what we call opposite rays, which means that they form this straight line that we talked about in the definition of the linear pair. And so what happens if that's the case is that we have some very specific information about what these two angles add up to be. Some of you may have learned about what's called a straight angle in the past. So this part of the diagram is a straight angle. Straight angles always have a measure of 180 degrees. And so the linear pair theorem says that these two angles that we just talked about that form a linear pair must also add up to be exactly 180 degrees because they form that straight angle together. So if we're using this figure that we have over here at the left and they give us the measure of angle JHI as 50, I'm going to trace from J to H to I, and right there in that corner, that's going to be the 50-degree angle they're talking about. They would like us to find the measure of angle GHJ. So angle GHJ is the other part of that linear pair. So our general equation is going to take those two angles, the measure of angle GHJ and the measure of angle JHI, and add them together. The total is always 180 degrees when we have a linear pair. So we'll substitute in our values. We don't know the measure of angle GHJ, so that will stay as is. But we do know the measure of angle JHI is 50. And so then with a quick subtraction, we'll be able to say that the measure of angle GHJ is equal to 130 degrees. And this linear pair theorem would be the reason that we would give to go along with that solution. The definition of linear pair is just what we're looking for so that we're able to use the linear pair theorem to actually solve the problems.